Okay, now we can do question C. The question says that simplify 1 there. It is 4 to the x times 4 to the x times 4 to the x. Okay, we could do 4 times 4 times 4, but it's going to be quite a long process. What we can do here is to write each of these in terms of the prime factors. Okay, so 4 is like 2 squared, 2 squared, 2 squared. Now, if we times, okay, over here we will times exponents, because that's the law, one of the law of exponent that says a to the m raised to the n is just a to the m times n. So this will be equal to 2 to the 2x times 2 to the 2x times 2 to the 2x, and then this is equal to 2 to the 6x, okay? Because here we will add exponents when we have like common bases. Okay. Now we will do question 2. Question 2 says 4 to the x plus 4 to the x plus 4 to the x plus 4 to the x. So in this case, note that the bases are common and the exponent also. It's like having not just the basis. Okay, first of all, the sign here, the operation here is not a multiplication operation, it's a sum operation, they add. Okay, there is no rule, specific rules for this among the laws of exponents. But in this case, I'd like you to consider it as the same thing. So this is the same as that, same as that. So it's like having like variable n plus n plus n, n, triple n, so that will make 3n, okay? So it's like the 3n. Instead of writing n, I can just say 4 to the x. This is the simplest form. Or we can also write 3 times 4 that can be written as 2 squared. And then you can continue by saying 3 times 2 to the 2x. This is also correct. Okay. And then with question 3, the question says that 4 to the 10, okay, plus 2 times 4 to the 10, plus 3 times 4 to the 10. Simplify this. Again, here we have like this and that are common. We can just call it n. This is n, another n there. And then understand that there's an invisible 1 here. So it's like 1n plus 2n plus 3n. Okay, 1 plus 2 plus 3 makes 6. So that makes 6n. So I just want to say 6 times 4 to the 10. Okay, and then this can be written as 6 multiplied by 4 to the 10 can be written as like 2 to the power 4. Okay, it's like 2 to the power of 2, and then this is like 6 multiplied by 2 to the power of 20. So it's also you can write this, you can write that. Still correct. Okay. Or we can also simplify further. You know, 6 is also if I say this is correct, that is correct, we can also go further. 6 is like 3 times 2, so times 2 to the 20. So, and then with the 2 here, raised to the power of 1. If someone says also this can be 3 multiplied by 2 to the power of 21, is also correct. So this one, that one, or that one are all the simplest form of the same expression. Thank you. Well, we have another question here, question D. That is, what is 1/2 of 2 to the power of 24? Okay, question D1. We're looking for 1/2 of 2 to the power of 24. Let me write here 2 to the power of 24. Half of it. So it means this divided by 2. In other words, okay, half of it means divide this by 2, or just make it over 2. Okay, I'll go for divide by 2. Divide by 2 and over 2 is the same thing. So this means 2 to the 24 divided by 2. The law of exponents says what? A to the m divided by a to the n equal to a to the m minus n. So in this case, it's going to be 2 to the 24 minus 1, because there is an invisible exponent here, 1. So we're going to do 24 minus 1. So this is equal to, okay, I should have put the equal symbol over here. And then this is equal to 2 to the 23. That's half of that. Now, and then question 2 says, what is 1/6 of 6 to the power 36? So 1/6 of it is means multiply that or divide by 6. Let's say divide by 6. It means divide by 6. Okay, or multiply by 1/6, the same thing. So over here also understand that the power, there is an invisible power of 1. So we're going to apply the same property. Okay, that would be 6 to the power of 36 minus 1, and then this will be equal to 6 to the power of 35. That's question D. Okay. Now we have question E. The question says that show that 8. Okay, as you can excuse me, show that this expression here is equal to 2 to the power of 26. Now I prefer to write each term of the expression in terms of the prime factors. Okay, so to the power of 8, 4 to the power of 12, 16 to the power of 6 plus 24 plus 2 to the power of 24. This is already, 2 is already a prime number, so 2 to the power of 24 equal to 2 to the power of 26. Then 8 is like 2 to the power of 3, 4 is 2 squared, 16 is 2 to the power of 4. And then this means, you know, the law of exponents says that any number a to the m raised to the power of n equal to a to the m multiplied by n. So we're going to apply that property over here, over there, over there. So this will be 2 to the 24 plus 2 to the 24 plus 2 to the 24 plus 2 to the 24 equal to 2 to the 26. Now that we have like over here we have this, sorry, we have like, this is the O same, we can call it a variable like n. Okay, n there. So that makes like 4 n's. So, instead of saying 4 n, I'm just gonna say 4 times 2 to the 24 equal to 4 to the 24 equal to 2 to the 26. Then 2 to the 24 is also as 2 squared. Okay, 2 squared, and then multiply by 2 to the 24 equal to 2 to the 26. And then another property says that a to the m multiplied by a to the n, this is equal to a to the m plus n. So when there are same bases here, like this, we're going to add the exponent. So it makes 2 to the 26 equal to 2 to the 26. And then the left hand side is equal to right hand side. So then now we're going to do question E2. Let me write here. The question says, prove that, like E1, prove that 3 to the, what was that again? 3 to the 30 is greater than 4 to the 20. Okay. 3 to the 30 is greater than, to prove this, is greater than 4 to the 20. When the question says prove that, it means it is so, but we just need to demonstrate it. Okay. I will look at what is the highest common factor of 30 and 20. Okay, the highest common factors here is just 10. So I can write it as 3. Instead of writing 30, I will write there 10 times 3, okay? Like 10 times 3 greater than 4. That also is going to be like 10 times 2, actually. 10 times 2. Now, this can be written as like to the power of 10. Okay, we can write it like according to this law of exponents. Okay, remember that a to the m times n equal to a to the m multiplied by n, like that. We can do the same also here. Okay, this can be written as 3 to the 3 to the power of 10. It means 2 to the 10 times 3. Okay, same also over here. It's going to be like 10 there and then 4 to the power of 2. Okay, now look at this. 3 to the power of 3 is 27. So like 27 to the power of 10 is greater than the 4 to the power of 2 is 16 to the power of 10. Now that we have common exponents here, power of 10, we can just look at the basis, okay? Of course, 27 is greater than 16. 27 is greater than 16, therefore, 3 to the 30 is greater than 4 to the 20. Thank you. Well, question F says if A equal to 1 plus 2 to the power of n and B equal to 1 plus 2 to the negative n, show that B equal to A over A minus 1. Now it means B is A over A minus 1. We just need to prove it, okay? Over here, B is 1 plus 2 to the negative n. 2 to the negative n. So this means B equal to 1 plus 2 to the negative n can be written as 1 over 2 to the n. Okay? And then we can write all these with a common denominator. So this would be like 1 can be written as 2 to the n over 2 to the n plus 1 over 2 to the n. Now that we have a common denominator here, 2 to the n and 2 to the n there, we can just add the numerator, okay? So this can be written as B equal to 2 to the n plus 1 over 2 to the n, okay? Then note that the numerator here is, this is just A, okay? Because A is 1 plus 2n, 2 to the n. So I can just write 1 plus 2 to the n over the denominator over here is just A minus 1, because this is like A is 1 plus 2n, 2 to the n, and then minus 1. If you minus 1, if you do minus 1, the denominator here, you retrieve 2 to the n. So that makes 2 to the n. So it is proven. So this is like, or I can write it like this. I want to show 1 plus 2 to the n over 2 to the n is just equal to A, okay, over A minus 1, okay? 2 to the n minus 2 to the n plus 1 minus 1. Proven. Thank you.